All right, so this is the general framework I would like to describe for the rest of our chapter. Well, X is the finite set of candidates, potential candidates. Sometimes I call them as alternative. Well, what do I mean by potential candidate? Well, it is someone who potentially may run for the office, but at the end may decide not to. All right, so you can think of this as all potential candidates, and some of which are going to participate into the election, but not all maybe. So X is the finite set of potential candidates. N is the finite set of voters, at least 2 voters in it, and UI. Well, again, I do not want to restrict our attention only on ordinal voting rules. We can also talk about cardinal voting rules. So UI basically represents each agent's cardinal preferences. All right, maybe I should write it here. Cardinal preferences. But don't forget, cardinal preferences will always give us what the agent's ordinal preferences are. So cardinal preferences is a larger than ordinal preferences in that sense. So for each voter I, a utility function UI is basically a function which maps each candidate to a real number. So basically it tells us not only how a voter ranks the agents, and the UI also tells us the intensity of the preference of the voter I over the set of candidates. Well, our assumption is that there is no indifference, meaning if 2 candidates X and Y are different, 2 different candidates, well then each agent are going to attach a different utility level to those candidates. All right. Well, the indifference is a technical. This assumption is for technical reasons. It makes our life much easier, but actually doesn't really kill the results. Everything we define here will work will work eventually if we allow indifference, but just the notation should be a bit more detailed, and we should be a bit more careful when we make some of the argumentations. So for simplicity, we assume that there's no indifference. So everybody, all the voters, prefer the agents or rank the agents strictly. Well, U sub X, that's an important notation, okay? Let's put star here. U of X is the set of preferences, an unrestricted preference domain, okay? Unrestricted preference domain. All right, well, what does it say? Well, it is the set of all utility functions that you can think of from set X into R without indifference, all right? So any utility function you can think of, well, then they are all included in this set U of X, okay? Well, a preference profile is denoted by U, so there's no subscript. Whenever I put a subscript, it means it belongs to an agent. If I don't have a subscript, it means a profile, a vector. All right, a preference profile U on U is a sort of a restricted domain, all right? So maybe the agent's preferences are well known to be in some category. For example, they never put candidate A as their first best, all right, maybe. So therefore, you can ignore all the utility functions where utility of A is the highest. All right, so in some way, the domain of preferences may be restricted. So if this is the case, we call it U rather than U of X. All right, so U is a subset of U of X. A preference profile, small u on capital U, is a vector, which is basically tells us the utility or the ranking, the preference ranking of each individual. And sometimes we denote it by U of I, comma U of minus I, all right? It means the preference of agent I and the preference of all the other agents or voters. All right, what is the ballot? Well, it's basically a subset Y of X, which consists of all the candidates who actually run for the office. All right, so remember, X is the set of all potential candidates. Some of them may not run for the office. Y is a subset of X. All right, so Y is a subset of X. It is basically the candidates who actually run for the office. So a voting rule, F, is a correspondence, not a function. So remember the difference between function and correspondence. Function will always give you a one and only one value for each element in its domain. But the correspondence may give you more than one value. So it's not one-to-one, all right? So the correspondence is going to give you more than one value for some of the elements in its domain. So a voting rule, F, is a correspondence that for each preference profile U and for each ballot Y, which is a subset of X, F of UY, which basically says the winner candidates. Again, this could be a singleton, this could be, this may include more than one candidate. So we denoted FUY because it depends not only on the profile, remember, our examples, but it also depends on the candidates, maybe not all. So if you remember our previous examples in the previous videos, we had 4 candidates, A, B, C, D. Well, maybe only A, B, and C runs for the office. And so Y is not A, B, C, D, E, but Y is this set, A, B, and C, all right? So therefore, if you change Y, obviously the value of F is going to be different. But whatever it is, the voting rule is going to choose some elements, some candidates in the set Y, okay? So that's how we describe the voting problem.